Water resource management. The main goal in water resource management is to provide a sustainable supply of high-quality water for human use and enjoyment. In order to understand how we might manage water, we need to understand how we supply water for human use. We build dams, we divert rivers, we use ocean water by desalination, and we also conserve what water we have. Let's focus on dams for a moment. Dams and other water impoundments are very disruptive to the river systems. The main reservoir of a dam often floods valuable land, often rich agricultural land. The dam structure itself will also slow the flow of water and cause sediment to be deposited, so ultimately the dam will fill in. With the change in river flow, the environment for aquatic organisms is altered, and so biological systems are changed. Fish migrations are blocked. Normal river flow and minor stream bank flooding, which is natural, is disrupted, often with disastrous results, as we have seen along the Mississippi River in recent times. Also keep in mind that dams are not the only way humans alter waterways. As you see here, aqueducts and other water diversions can greatly change the aquatic environment, making it far less natural and far more artificial. Desalination, simply put, is the removal of salt from water. The typical method for removing salts from ocean water is reverse osmosis. In this process, seawater is forced under pressure through special filtering membranes that remove salt and other dissolved materials and permit pure water to pass through. It typically takes about 2 gallons of seawater to produce 1 gallon of fresh water. For obvious reasons, desalination is limited to coastal areas, and currently the majority of these plants are in arid areas where higher costs of operation are acceptable or other alternatives are limited. Now let's briefly view some aspects of water conservation in agriculture, industry, and our homes. Agriculture is the single largest user of water worldwide, and the biggest use of water in agriculture is irrigation. And the biggest problem in irrigation is water loss due to evaporation. Simply put, farmers want the water to go on their plants, not into the atmosphere. Irrigation uses vast amounts of water. It can be as much as 10,000 gallons of water per minute in a typically irrigated field. The most efficient type of irrigation is flood irrigation. That's the most inefficient type of irrigation is flood irrigation, in which entire fields are flooded as water is delivered to the crop at different intervals by allowing it to run open in the field along crop rows. A more efficient system is center pivot irrigation. In center pivot irrigation, large pivoting arms move over crops, delivering water directly to the plants from overhead. This way, less water is lost to evaporation or seepage into the ground. There is, of course, still going to be some evaporation. A major environmental threat from irrigation, separate from water diversion issues and possible water contamination from fertilizers and pesticides, is salinization. Salinization is the accumulation of salts and minerals in excessive amounts in the soil. Salinization can hurt productivity and render soil unfit for farming. The accumulated salts damages plants, but also alters soils. Worldwide, it is estimated that 3.7 million acres of agricultural land is lost annually to salinization and waterlogging. As water is added to the soil, the water evaporates and the salts remain behind and accumulate. As a result, soils look like this and are not suitable for crops. Crop scientists have developed some crops that are resistant to salt accumulation. Perhaps a more promising approach is to find ways to reduce water use in irrigation. This would, of course, save water, but also slow the salinization process. One way is known as surge flow, in which water is only periodically introduced into the fields, much like you do with your houseplants, water only as necessary. Another important method of irrigation is drip irrigation. In drip irrigation, each plant receives water through its own individual tube. Water is supplied to growing plants through a network of tubes and pipes. Although this method is efficient, you can imagine that it is very costly due to the high infrastructure and labor costs of installing and maintaining the plumbing system. Strict environmental controls have improved water quality in U.S. and other industrialized nations. As a result of regulation, many industries have reduced water loss, recycle water, and thoroughly treat water before releasing it back into the hydrological cycle. For example, U.S. Steel recycles about 2/3 of the water it uses in its industrial processes. Municipal or home water conservation varies significantly from region to region or even household to household. The key to water conservation around the home is education. When folks understand how water can be conserved by repairing leaks and installing water-saving fixtures, they will often do so. Also, as water treatment costs rise and are passed on to the consumer begins to look for ways to reduce water use and waste and thus reduce their costs. One method employed in some communities is the use of gray water. Gray water is water from home use that does not include toilet and other organic wastes. So water from showers, laundry, kitchen, etc. can often be used directly for watering shrubbery or for flushing toilets, and with light treatment may even be used in other situations. So, with water management, we need to protect our sources, develop new sources, perhaps in salination, wisely use the water we have, and of course, conserve.